Hi, welcome to lesson 3.5, equations of parallel and perpendicular lines. Now, before we start, we are going to start actually on page 88. Okay, so while we're on page 88, please write down the problems that as to where we're going to do the problems. So example 2 is going to go right here. Example 3 and 4 are going to go right here. Now I'm going to start here before we start the exploration because there's two theorems that we need to know and understand. Now, when you guys are graphing lines, the lines are either the same line, coincident lines, or they're parallel, or they're perpendicular, or they're neither. So today we're going to focus on lines that are going to be parallel and perpendicular. And if you remember, the slopes have everything to do with how the lines are inclined. So what we have here is, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So here's the key word. They have to have the same slopes or equal slopes. So if the lines are parallel, the slopes of those two lines are going to be the same. Now, if the lines are perpendicular, that means that the product of their slope is -1. So I like to think about it as the opposite reciprocal. Okay, so if I look at this, the product of the slopes is -1. If I were to divide by one of the slopes, I would have technical difficulties with my pencil. Okay, I would have m1 equal to -1 over m2. I call this the opposite reciprocal. Okay, so here I never like to refer it as, the slope, the product of the slope is -1. Occasionally I do, but I like to think about it as are the angles opposite reciprocals of each other, or if their product is -1, then they're going to be perpendicular. Now, for the sake of the lesson today, you are going to need some equations from Algebra 1. Okay, so please turn really quickly to page 87, and let's review those equations just a little bit. Okay, so let's cross those off. Okay, so what you're going to need is equation of a line. Okay, now this is the standard equation of a line, where m is your slope and b happens to be your y-intercept. Okay, so you need to remember, these two pieces of information, because that is what's going to help us solve the equations, because today we're going to be writing equations of parallels and perpendicular lines. So let's get started, because there's plenty of them to go for. Okay, turn to page 86. And let's start with the very first one. Now I'm going to zoom in a little bit. Hopefully I'll have enough space. As a matter of fact, let me define my little boundaries here so that I know I have enough space. Okay. All right, so let's take a look at this first top two. Actually, no, I'm going to go left first and then top first. Okay, so on the left-hand side, I'm going to go with A first. What we have here is I want to know the equation of this line right here, okay, that has this slope and it's parallel to this one. So in order to do this, I need two pieces of information. I need the slope of the original line, and I need the slope of the line that is going to be parallel. Okay, so I'm going to put little subscripts on them like this. Okay, the original one has nothing. The new line, the new slope is going to be the one that has the m parallel. Okay, so now the original line, if you look at this one, the slope is 3 over 2. 3 over 2. So because I am writing an equation of a line that is parallel to this line, they're going to have the same slope. So that's going to be 3 over 2. Okay? So now the only thing that I need is a point on the other line. And it just so happens that it's going to be 0, 2. So this is the coordinate that it has to go through. So all we're going to do is we are going to use our slope-intercept form equation, plug the values in, and solve for the y-intercept. So the equation looks like this. Y equals mx plus b. Okay, I know, let me move it over. Okay, I know x, I know y, I know m, I do not know b. So here is my x, here's my y. Plug the values in. Here, I'm going to have 2. The slope is going to be 3 over 2. The value of x is going to be 0. And I'm looking for b. So here, 3 over 2 multiplied by 0, it's just 0. So 2 equals b. Which means now that I can write my equation. My equation is going to be y equals 3 over 2x plus 2. Okay, so that, ladies and gentlemen, is the equation of this line right there. Okay, let's take a look at the next one. We're going to look at C now. Okay, we're not going to go A, B, C in order. There's a reason why. All right, so here the slope of the original line happens to be 1 over 2. The slope of the line parallel to it has to be exactly the same because they're parallel. Okay? Now the coordinate that it needs to go through is 2, negative 2, which is going to be my x and y. So what I'm going to do is I'm going to plug those values in to my equation. Okay? So then that's just going to go in there. The value of y is negative 2. The value of the slope is 1/2. The value of x is 2. And then I'm looking for b. Okay? So now I multiply. 1 times 2 is 2 divided by 2, that's 1. So that's negative 2 equal to 1 plus b. I subtract 1 from both sides. And I get b equals negative 3. So with that y-intercept and that slope, I can write my equation now. And that equation is the equation of that line. Let's take a look at E now. Okay, for E, the slope of the original line happens to be negative 2. So the slope of the line parallel to that one has to be also negative 2. And it has to go through this point. 0, negative 2. Which is going to be my x and y. So once again, my equation, mx plus b, okay, you're going to plug those values in. X is 0, y is negative 2. Negative 2, the slope is also negative 2, multiplied by 0 plus b. So that right there is going to be 0. So negative 2 equals b. So that gives me my equation. Y equals negative 2x minus 2. And that is the equation for that line right there. Nope, not that line. That line right there. Okay, so the process for the remaining 3 is exactly the same. The only difference is that the slopes are not equal. They are opposite reciprocals. Okay, and that's what we're going to look at right now. Okay, Okay, so let's go up to B. Hopefully I have enough space. Okay, so here, I'm going to write this part down here instead. Okay, so here, the slope of the original line is 3/2. Now, I want the slope of the reciprocal. I want the slope of the line perpendicular to that, so it's going to be opposite reciprocal. So how do I do that? Very simple. Flip it and change the sign. Okay, so right now it's a positive, so it's going to be a negative. Keep the negative at the top. Okay? And because it's 3/2, when you flip it, it's called a reciprocal, you're going to get 2/3. And it needs to go through the point 0, 1, which is my x and y. So now I got to do the same thing. Okay? Before it didn't matter because the slopes were all the same. But here I need to use this slope, the one that's perpendicular to the original. Okay, that's the one I got to do. Just remember, flip it, change the sign. Okay, so the process after this, it's exactly the same. Okay, so for y, you're going to put 1. For the slope, you're going to put -2/3. For x, you're going to put 0. And guys, sometimes you're going to get a really messy fraction. That's okay. Do what you can. That's going to be 0, so 1 is equal to b. Which now, if I have the y-intercept and the slope, I can now write my equation. Y equals -2/3x plus 1. And that is the equation to that line right there. Okay, let's take a look at the next one. Okay, so the slope of the original line, according to this, they tell me it's 1/2. So the slope of the line perpendicular to that is the opposite reciprocal of 1/2. So remember, flip it, change the sign. So if you flip 1/2, you're going to get 2/1. And 2/1, you know that's just 2. But we want the opposite of that. So that's going to be -2. And it needs to go through the point -2, 3. So that's my x, that's my y. Okay? And now all you got to do now is plug it into the equation like we've done in all the problems. Okay, the value of y is -3. The value of the slope, this one, not this one, don't use the original one, otherwise you're going to get the equation of the line parallel to it. That's not the one you want. So that's -2 times the value of x, which is 2, plus b. Simplify it. That is -4 plus b. And now you're going to solve it for b by adding 4. And you get 1 equal to b. So now you have the equation y equals -2x plus 1. And that is the equation of that line right there. Okay, we have one last one. All right, so here the slope of the original line is -2. So how am I going to get the slope of the reciprocal if it's not a fraction? Easy. All you got to do is put a 1 under it, flip it, change the sign. So if you flip -2/1, that's just 1/2. And the opposite of -2/1 is positive 1/2, you know? So that's going to be 1/2. Okay, and it has to go through the point 4, 0. That's going to be my x and my y. Plug it into the equation. Do you have to write this equation all the time? If you get the hang of it, no, just go straight to the work. So y is going to be 0. The slope is going to be 1/2. The value of x is going to be 4. And plus b, because your goal is to solve for b. 4 times 1 is 4, divided by 2 is just 2. So 0 equals 2 plus b. Minus 2 minus 2, b equals negative 2. So now I can write my equation. Okay, like this. And that's the equation for that line. All right, now we are going to skip some problems, okay? Mainly because there are some objectives that are in this lesson that we are not going to cover, because that'll literally take me another full day to teach, and it's not a very relevant concept. So we are going to skip a few examples, okay? We only technically have 3 examples, but I'm going to number them in the way that they are in the textbook. Okay, so the first example is not going to be example 1. It's actually going to be example 2. So let me tell you where those are going to go if I haven't done so yet. I think I did already. They're going to go on page 88. Okay, so 2, 3, and 4, that's where they're going to go. Okay, so there is no example number 1 and there is no example number 5 either. So let's take a look at example 2. Okay, so for example 2, it says determine which of the lines are parallel and which of the lines are perpendicular. Okay, so here's what we need to do. We need to figure out what are the slopes of all 4 of these lines. So let's look at line A. Okay, let's look at line A. Now, line A has these 2 points right here. Okay. Now, you could do the equation for slope. I'll write it up here. If you don't remember it, remember it. Okay. You can use that one, or you can simply count because you have the graph, so you can use rise over run. So for A, you have these 2 points. So from here to here, my rise is 1, my run is 3. So my slope is going to be 1 over 3. Okay? 1 over 3. Remember, rise over run. Then you have line B. That's this one. So you can use this point and this point. So this is going to be 1 over 2. So the slope is 1 over 2. Let's look at line C. That's this one and this one. Once again, 1 over 2. And the last one is line D. Okay, so for line D, I'm going to use this point and I'm going to use this point right here. So this is going to be the rise is 2, the run is 1. So that slope is going to be 2 over 1. But if you notice, the line is going in the negative direction. So that's going to be negative 2 over 1. So now the question is asking which ones are parallel. Well, you got to determine which ones are the same slope. So as you can see, lines B and C happen to have the same slope. Okay, so what you're going to do is these 2 are the parallel ones. So these 2 are the ones that are parallel. Okay, so we can say that B is parallel to C. Now, do you have to copy down the graphs, guys? I honestly don't think you have to. If you want to, go ahead. If not, just make sure you're writing down this information that we're doing here. Okay, so B and C are parallel. Now, which ones are perpendicular? Remember, the product of the slopes has to be negative 1. So obviously, if you multiply these 2, that's not going to be negative 1. If you multiply these 2, that's not negative 1. If you multiply these 2, that's not going to be negative 1. But if you multiply this one and this one, okay, if you multiply 1/2 times negative 2 over 1, that product is going to be negative 2 over 2, which is indeed negative 1. So that means that line D is going to be perpendicular to both B and C. Okay? Now, if you have the graph, guys, it's so much easier than having to use this equation up here. But if you don't have the graph, guess what? You're doing that. Okay? So remember, parallel lines have equal slopes, perpendicular lines have opposite reciprocal slopes. Okay. Now, for the next two problems, guys, we do not have the graph. We don't need it. So let's look at example number 3. It says, write an equation of a line passing through point -1, 1 that is parallel to the line y equals 2x minus 3. Here's our main information. We want the lines to be parallel, which means that the slopes have to be equal. Okay, the slopes are equal. So what is the slope? The slope of this equation, now this equation, guys, is in this form. That's the slope. It's solved for y. If it's not solved for y, guess what? You got to solve it for y first. So the slope here happens to be 2. That's the slope of the original line. So the slope of the line that's parallel is going to be also 2. So I'm going to use this slope, and I'm going to use the coordinate that they're giving me. This one has to go through this point. Okay, that's going to be my x and y. And then we're just going to do what we did in the exploration. So that's going to be y equals mx plus b. Y is 1. M is 2. And the value of x is -1 plus b. So that's 1 equals -2 plus b. We're solving for b by adding 2. And b equals 3. So what am I going to do with that 3? I'm going to use it to write my equation. Y equals, my slope again is 2x plus 3. And that is the equation that I am looking for. So what does all this mean? It means that if I have this line and I have this point not on the line, this is the equation of the line that is parallel to this one but going through that point. Okay? Now, on the last one, example 4, the process is the same, but your slopes are not. Okay, so it says, write an equation of a line passing through that point that is perpendicular. Okay, perpendicular, not the same. Two lines, 2x plus y equals 2. So I need two pieces of information. The slope of the original line and the coordinate. The coordinate is given to me. Okay, now, when I get this, then I can figure out what this is going to be. Look at that. If you're thinking the slope of this line to be 2, you are not correct because that is not solved for y. Okay, so let's fix it. If it's not solved for y, fix it. Solve it for y. I'm going to solve for y by subtracting 2x. And y equals -2x plus 2. Okay, now I got my information. The slope, the original slope, is -2. The slope of the line perpendicular to that is the opposite reciprocal of this, but that's not a fraction. Make it one. Put a 1 under it. Flip it and change the sign. So the reciprocal of -2/1 is 1 over 2, and because that's a positive, that's a negative, my opposite is a positive. So I'm going to use this slope and that point to figure out the equation. So once again, y equals mx plus b. Okay, so we're going to get 3 equals 1/2 x. The value of x is 2 plus b. Now 1 times 2 is 2 divided by 2, that's 1. u minus 1, b equals 2. Which means that my equation is going to be 1/2 x plus 2. Now guys, sometimes you're going to get a very messy fraction, and that is okay. Okay? All right. Now, before we end the video, okay, there are a couple of examples. There are some problems from your extra practice that I do not want you to do because I did not teach you how to do it, and I don't want you guys to stress over, I don't know how to do this, you didn't show me in the video. Okay, so if you go to your journal on page 89, okay, page 89, I want you to cross off problems 1 and 2. Okay, cross off problems 1 and 2. And then on the next page, on page 90, I don't want you guys to do number 7. Okay, don't do number 7. Now, on 5 and 6, you are going to do that, but you're also going to be graphing them. Don't forget the graphing. Okay? All right, guys, have a great day, and we are done for today.